Welcome again to another tutorial. In this case, we're going to learn how to create a really nice animation with Veldum. So you can create any kind of cloth or bubble or whatever you want simulation, and it will look just fine. So stay tuned and watch the full tutorial.
Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We will have resources for every type of discipline. So hop in and have fun. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance. So if you are interested, you may have a look. Thank you.
Welcome again to another file. So this is the whole scene, and this is the camera. You can see when it moves, it follows the character, which looks pretty good. So how do we make all of this? So let's hop into our scene. First of all, you need to download any character you want from Mixamo. I chose this character with this rig, and we can see it has this animation. I'm going to put the background black so we can watch it better. So once we have everything like this, we need to create these nulls because we're going to reference it later on, and we're going to use a point, or a bound deform to create the animation. This is what we have. Secondly, we reference the T-pose, which is this one, and we do a convex hull because we want to separate each of the pieces. As you can see, if we do an exploded view, we can see that the pieces are separated in shapes. We can do a BDB from polygons to basically have this kind of shape and smooth it out to our liking. We are then going to convert this shape back into polygons. These are values I decided. You can use whatever you want. And I painted some masks which are here. There we go. These are the masks, because in one case I wanted to paint on, I wanted to scatter everywhere. On another case I only wanted to scatter on the arms, because we're going to fracture the shape of this guy with these scatters. So as you can see, one scatter is for the arms and one scatter is also for the body, and this is the Voronoi. Secondly, finally here we select the Voronoi and we go on a for each piece. Remember, we have the name attribute called piece. If we open the geometry spreadsheet, we do have the names here from 0 to 41. So this loop for each named primitive, is going to loop on each of the pieces. So let's say we're going to have a look at this one. We're going to BDB from polygons, BDB smooth, and convert it. Then we are also going to remesh it, so it's very nice for Veldum. This is not so good, but this is way better. We're going to smooth the normals a little bit so we can pick. Look how it looks without the smoothing normals. I think it didn't change anything because I am supposed to have the normals on points. So this is how you should do it. Once we have this, we're going to get the T-pose rig, which is this one. I decided to delete the fingers. To edit the neck, I select S with the points and just press the letter T and move it. And basically I did a poly wire. This poly wire is going to determine where our shape is basically grouping. I increase the peak so I can have less points. Then I transfer those groups back into the original geometry, which is the remesh. I'm going to turn this on. In the meanwhile, you can have it turn off, on, it doesn't matter, but I didn't use it in my scenario. You should be using it. I'm going to do a for each on every single shape. This is going to be automatically, and we will have something like this. So we went from this to this. Moving on to our next step is to actually create what we are calling the Veldum constraints. So first of all, we're going to group the body points on a group called body. We're going to delete everything, so we only have body and pin groups. and also the position, nothing else. We're going to use a Vellum distance. We're going to grab the body. This is in case you have more geometry than other than this Vellum. We're going to use these settings. The stretch is going to be 10 multiplied by 0.01, so it's a little bit soft. We're going to have some pressure, same at the body. These are the settings, nothing else. I only change 1 to +8. This is the only thing I'm doing. And we're also going to use a Vellum constraints, but pin to target. We're going to grab the pin and we're going to match the animation in case there is an animation. In this case, it's static. We're also, before starting our simulation, we're also going to make kind of an expression on how this should be exploding or getting bigger. So we're going to grab the bubble, which is the same as this one. We're going to add some normals on points. We're going to blur these normals. We can see how it looks with and without the normals. We're going to pick and we're going to smooth. So this is the idea behind it. The normal blur is to basically having more uniform distribution, and the smooth is to make it even more obvious that it has to be uniform, the distribution of polygons. When we hop into the solver, the only thing we got to do is to connect this Vellum rest blend, use these groups. Remember, these groups can be get here, right on the output group stretch, and here output group stretch, and nothing else. I decided to also use the bend attribute because I only use the stretch, sorry, but you could be also using, apart from the stretch, the bend one. I don't have a bend group here, so it's not going to make a difference. We're also going to be updating each frame, or you could also be using each substep, but since I only have one substep, it is pretty much the same. So one frame or one substep is not going to make a difference in this scenario. So once we have this, we can play with it. And remember, we are also connecting the SOP out rest, which is this one, which is the bigger one, which is what we want. Also, this is animated from 0 to this value, so it's an animation and it's not going to explode immediately. We are also going to have a look at this. We're going to allow the simulation here. We're going to press play and see what happens. As you can see, this is expanding and it's colliding very, very nicely. We're going to use one frame, which is 1020. This is our shape. Yeah, now you can tell there are tons of attributes, which we are going to get rid of all of them, and we're only going to be with these points. We can even delete the stream default source, but since I'm not even using it, or the Vellum option, I'm not even using it, I just didn't care too much. We're going to save this on a file cache and move on. When you get to the pre-bubble, this is what I call the pre-bubble, which is this one. Again, we're going to make something else. In this case, we're going to make the strings. So let's make a peak, a really big peak. Let's make a sphere and let's scatter some things. These scatters are the same. We are Ctrl-Shift-Alt and drag, and we create a reference. The only thing I created different is the global seed. With Ctrl-Shift and click, you delete the reference. So it's the same amount of points, or not? No, it's not the same amount of points. It's one is 100 and one is 15. But we're having some IDs on both of them. So we're going to from 0 to 100 and from 0 to 14. We could even use 15 here. It's going to be the same, but just move along. It's not a very expensive task. So when we connect all the points like so, what we are trying to do here is to have some shapes connected. It looks kind of stars right now. We need to clean this, we need to polypath this, and we need to resample. The polypath is basically so we can allow the resample to do its job on smoothing it out. We're going to do a connectivity on primitive so we can loop per piece, and inside of those we're going to add another resample, as you can see, which is a little bit more detailed. and we're going to add this code. This code basically, I know this is not the most efficient way, but this code, what it does is creates a group on the end and beginning and at the end, so we can grab it later. This is called start and end. We are going to do this for each of the groups, and now that I can tell this could be deleted. It doesn't really change at all anything. We are, remember, keeping the rest length, which is this one, just in case, and we're naming these on points as strings. We are grabbing the bubble, which is what we got. This is the bubble up, this one, and this is the pre-bubble. This is the bubble up, and we're using this group. This well, we are not using a group because we don't need a group to begin with, but we could if we go to points and we could select the strings, which is pretty much the same. There's not any other geometry, and we with the collider on the next input after we put all these values, which is only making it a little bit larger and lowering the stiffness from 10 to 8. Nothing else. This is very basic. We're going to use this with the collision. We're going to use an attached to geometry. We're going to select on points the end of the start that we created here, and we're going to move to create this max distance. Also, this is very important, the radius length is going to be 0. This means that once it begins, it will retract automatically to the collider. Nothing else is changed. When we press play, these are the settings. They are default basically. When we press play, they will all go to their position, and I'm going to choose a value I like. I also deleted some of these constraints, some of these primitives, because they looked awful. I just selected with the letter S. Item shifted this to a value I want. I think it's 10 or 40 in this case. Yes, 10 or 40, and I deleted all the attributes again. I just keep the groups, the strings, start, end, and these two, which could be deleted if you wanted to. Then I save this into disk and I move on to the next and almost final steps. What I have to do is to create or to grab the bubble up again and to create the T-pose rig. This is very important. We need to do a connectivity and delete the small pieces. As you can see, this is the only small pieces I found. We're going to go one by one. So we're going to BDB from polygons. We're going to smooth it and we're going to convert it back into polygons with the same remesh method as before. What we're going to do is a TET conform. The TET conform, if you press W, you will see there is geometry inside. This will basically allow us to have more control over our final look in the simulation. It's going to keep the volume. So then we're going to select, we're going to use this mesh, we're going to delete the fingers, we're going to increase the neck again, and we're going to polywire. We polywire everything, and we're going to pick selected areas we want. I recommend you choose this. This has to go at least on some part or another of our shapes, because we're going to use this as a pin later on. Everything that is inside is going to be moving the geometry. So as you can see, I selected pin here. I picked this. I also, what did I do here? This is a pick. This is another pick. I think I wanted to, yeah, I basically did everything on the same wrangle. And this is not doing anything, I believe. Yeah, it's not doing anything. I will keep it on just in case. And I moved these polygons inside. I don't want to have any surface in whatsoever, only volume. This is very nice. You can use whatever technique you want to group them. And I'm going to do another pick to increase the leg width. As you can tell here, you have a more solid area of contact. I'm going to pin all of these values based on the bounding box. If we do a blast and we basically, well, you can see it here is right there. We can go on a for each. It's going to go piece by piece doing the same settings. And we can basically grab our pin and do the inverse so we can see better what's going on. This is what's going to be driving the animation. Now I think that you're having an idea of what's going to happen. We're going to convert. I don't know if this step is totally necessary. You can try with and without. We're going to group all of this again and call it body again. We're going to get our or grab our prepare shapes, which are here, the strings. Prepare. Oh my god, that's a really hard name. And we can tell that this is not necessarily touching the surface. We could change this. For example, if we do the array and we select the end and the start and we select the scale of 0.099, we are basically merging again the strings where they belong. This is very important. Final step, we're going to go into the presim, which is this one. We're going to grab our T-pose, which is this one, and this is the animation. We're going to do a blend from T-pose to the animation because the starting point is different and I want to have the T-pose at the beginning. So this is the blend shape, as you can see. It's only an animation. And this is going to just be grabbing the pin. These are the settings. And you can see this looks very awful, but this is good enough. This is good enough for our simulation. Moving on, we're almost about to finish. We are grabbing our presim and we're doing, hey, I want a distance on the body. These are the settings to make it kind of stiff, but not so stiff. This is the TET volume. The TET volume will grab from the body the whole shape and make it blobby. These are the settings. And remember, on all of these, I'm keeping static topology because this is not changing. It is going to improve your overall simulation time a little bit. We're going to use pin. Okay, so the pin, let's go to the first frame. The pin has to go on, well, basically what's moving is the pin. And I'm saying, hey, match the animation. And the animation is this one, what we are watching on screen. So this is going to move, whereas this is not. This is only going to be affected after the fact. That's all it is, nothing else. The strings, obviously I'm selecting the strings. This, what's going on here? Nothing is happening here, strange. I'm selecting the body. No, I'm selecting the strings for the strings. And I'm selecting the string constraint type and using this rest length. So it's a little bit less or more loose. This is the stiffness and the static topology again. And I'm welding those. This is key, this is essential. The welding, you are not going to see it here, but basically I'm welding the end and the start to the body points. That's how it is going to grab all of these points and basically weld them to the surface. So we're going to have this simulation. In this case, I'm going to start on the 101. This is the velocity damping. On the solver, I'm only going to use 4 sub-steps, nothing else. Let's have a look again at the settings. So you can just copy and paste in case that you missed out on something. This is real scale, so this is roughly 1.7 meters. And that's about it. There's nothing else. There's a little bit of damping. Damping is always nice to have on a small value. We can then grab a volume IO to save everything. I didn't save anything, that's why it's from this is turned off. I'm splitting then the surface points, as you can see, and you're also splitting the wires with the strings right here. So why I'm splitting this? Because I want to have this smoothing operation with the spatial blur of 0.2, and there is an issue here because if we have a look, we're having again this separation, which is minimal, but we do have them. So what we have to do is to just rate those points back to the surface with the minimum distance. This will solve everything. If we resample this, it's going to smooth out everything. And with a polywire with these settings, when egg division and merging both things, it's going to give us this. We're going to delete everything but the body and the strings. We're going to delete everything but the velocity. And we're going to save this with a rest position on frame 101. This is a set names. The only thing I'm using or I'm making here is basically hopping in, having a connectivity set to primitives. This is going to add the class attribute, and I'm adding the following code. Name is equals to the name, which is written here. You can put any kind between semicolons. You can say piece, plus the integer to a string, which is I at class, which is this one. So each piece is going to add the name piece and add the class as a string on primitives. Remember, this has to be on primitives. So copy this, and add a connectivity with a primitive behind this. This will allow us to have these visualizers. Remember, I'm visualizing this with the control middlemost click name. See, I'm clicking here so we can visualize it. Then I'm saving the simulation, which looks like this. Okay, I didn't save it. Yes, I saved it. So this is how it looks. It looks very nice. It looks flawlessly. Very nice, very nice. So let's grab our simulation. And what I did here is a mistake, but I selected piece by piece and split what is the string from the group, from the body. Because beforehand I didn't have the body and the strings group. So this, changing this for just body, if I saved it, which I don't, should be the same. You should be putting body here, not these selections. I'm going to, on both sides, going to do the same. I'm going to select a primitive, the primitive class, and turn it into a float. So this is now a float instead of integer. I'm going to promote this into points, from primitive to points. I'm going to make it a vector because I want to transfer this as a vector data. I don't know why I decided to do it like so, but it works. To Karma. Then I did this hue ramp, which this hue ramp, remember we have how many points here? Is going from 0 to 40. So then I hop in. I basically selected the class with a bind. I selected the vector float because remember now it's a float. On the X value, I connected into a fit from 0 to 40 because we have 40 pieces. And then I did a ramp which exported to the class, and also the CD because I wanted to look, I wanted to see how it looks. And these are the colors. We can change these colors with the class and this ramp. Then I redo the normals to points, and the rest is being multiplied by 1000 because it's not as easy as you might think to make something in Karma. It still needs some attributes which I had to control via subs. That's why I'm doing this on subs and not in the shader network. This is exactly the same, but instead of being from 0 to 40, from 41 to 90. So the only thing I changed is these values, which output equally. Finally, but not less important, I blasted one piece of the face, and I have a box which I am then caching. This is very important, cache it to this, because this is going to be expensive if you don't do it, which is basically following the head. What I do want to do is to basically export this to Chops and add a filter with these settings. After importing the geometry from Chops, this should be animated. This is the filter with this value. This is the delay with this value. What this is going to do once we apply it back into the ChopNet, into SOP, sorry. And this, the only thing we had to do, ChopNet, which is this one. We're going to drag it here and add animated, because this is animated. What this is going to do, if we look at both on camera, is going to add like a little delay. Let's look at it without the camera. This is the original, the wireframe, which is moving very erratically. And as you can see, the white one is very, very soft, and it has some kind of delay, right? So this is what we want to use our camera as a target. If we look at the animation, which is this one, and we look at our head, this is what we are visualizing. As you can see, it's like a delay animation of the face. It's like I am trying to focus you, but you're moving too hard. So look at this. It's moving. It's very nice effects, and it's pretty much free. So we're going to save the static transformation and the out anim transformation. We're going to visualize this, and we're going to go back the only thing we got to do is to do an extract geo. On source geometry, we are going to use the out static, and on destination, the out anim transformation. We are not going to extract the rotation, otherwise this is going to look kind of off. And we're going to adjust our animation with a null if we need it. So this is how it looks. If you want to change the orientation, you just change the orientation with the lockpick with the lock. So you can do this, and it will just focus the camera, as you can see. And I'm going to go back because this is the animation I really liked. And I use the null just so we can move it to the side or to center it, so that you can decide how you want it. And this is basically the whole tutorial on this on the simulation. So let's move very fast to Karma, to stage. So on stage, what I did is to import the spheres, which I separated from the lines, as you remember, and to export the lines. These are the spheres, and these are the lines which import the color data. Then I'm going to go into the material. This is basically, the material is a standard surface with coat, with subsurface, with this is the scale, this is the specular, and I'm using the class because I exported this CD or this color as class, as a float 3 to the base color and the subsurface color and the subsurface radius. Finally, I added a frame reader with the rest. Remember that I multiplied the rest by 1000. Well, it was because I wanted to control the position of this noise, and this noise has this amplitude and this displacement connected into material surface, material x surface material. So this means that if we go very deep into our simulation and we do our render settings, well, we're not going to see anything because of the motion blur, of course. But if we disable the motion blur, we will be able, in theory, to see some displacement. As you can see, there is a little bit of displacement, which might add if you have a lesser moving animation. So we can go back into our camera. With the lines, it's exactly the same. I didn't change anything whatsoever. Same material, which I could have only used one. I don't know why I chose two. The only thing I did here is to add a geometry render settings with the dicing turned on. I could also do it on the lines, but I decided not to. I just created a stage. The stage is basically a grid with some spheres and with some class attributes. This is the color. Instead of using class, I use a value called color, which I created. I decided to plug the color into the base color, nothing else, pretty much. And I imported the cameras to Cam2. So scene import cameras, scene import cameras, and I chose the camera 2. I merged all of these guys together. I added a simple downlight with intensity of 2. It has this HDRI, and I decided to use these render settings. I have motion blur with velocity and velocity. I should be deleting the depth of field because I'm not using it. These are the limits, all to 10. The image output I'm using on the component level, the beauty. So on the beauty, on the direct diffuse, the indirect, the glossy direct, the indirect glossy, and I also want to have the subsurface with position, depth, UVs, and normals. And I also using an extra render bar for the crypto matte, which we can all look at these values through here. Is the crypto, which depends on the name. So you need namings. It's very important to have names so we can select all the geometries and the crypto matte works. We need to have depth. As you can see, there's something going on here. This is the depth, and we have all of our render passes right as we need. And then I think nothing else is going to be added here. Yeah, this pretty much is the resolution I decided to use, and that's about it. Remember on these settings just to add the Cam2, and this is the render output I decided. And once you are happy with your render, how it looks, you just click on render to disk, and remember to disable the instantaneous shutter. So I hope that you enjoyed the tutorial. Hey guys, again, welcome back. So I hope that you enjoyed the tutorial. Please leave a like, subscribe, comment if you have any type of doubt, or you can even join the Discord channel, link down below. So yeah,